All right. Well, welcome. Today we're here. Vincent and I'm Scott Donaldson. This is Vincent Solis, my colleague. We're from FINRA, and we're here today to talk about building a secure data science platform on AWS. We're going to give some of the tips and tricks that we did, kind of like along the way, and what was our story of kind of how we got to having our data science platform for our data scientists up there. Before we begin, let me just give just a real brief background into who is FINRA. So we regulate the stock brokerage industry. So all of the stockbrokers, if you're, think of it sort of the bar exam for the stockbrokers if you want to be a licensed broker-dealer. We also do the market regulation for various different exchanges. We do this for virtually all of the equities exchanges like the NASDAQ and NYSE, and we do it for about 2/3 of the options exchanges like the CBOE. And in doing so, what we do is that we bring in a wide variety of different data sources, over 700 various different data sets from exchanges, from external firms, from the broker-dealers, from industry sources like Bloomberg, Thomson Reuters, News, et cetera. And so we bring in all this information, we correlate it, we coalesce it, we normalize it, get it prepared for analytics. And from there, we basically reconstruct the market after the fact. And the ideas around this is that we do things, we're doing compliance reviews, but more importantly, trying to do investor protection and market integrity. So we look for malfeasance in the market, things like insider trading, for fraud, for various different market manipulation schemes that might be going on that could disadvantage any individual retailer. So when we look at When we were looking at it a couple years ago, we were looking at migrating our platforms from our own internal data center up onto the cloud. And when we looked at this, we looked at what were our needs, specifically around the data science needs. And many of these are the same for any of our various different analytic applications, whether it be for ad hoc query or doing any sort of research. So things like data discovery that we wanted to be able to address, make it easy for them, understand the semantics of the data, that we needed to be able to bring together disparate sources of data that were laying out in these little islands and pockets in various different databases and data warehouse appliances. So bringing that all together. One is we wanted to enable the users. Really, we wanted to get technology out of the way. So many times in any sort of data science project, the vast majority of the time is spent coalescing the data, cleaning the data, cleansing it, as opposed to actually doing the real, I'm not doing statistical correlation, I'm not running these classifiers. You're spending all of this time. So how do we make that simpler, easier for the different data scientists that we have? We needed to be able to do this, and we needed to actually protect the data. These are financial records that we're bringing in. They're coming in from the firms and from our various different exchanges. So security is extremely important, and moving it up onto the cloud. So we employed a wide variety of different security techniques around this in terms of of encryption, both in transit and at rest, use of IAM rules, et cetera. And we'll go into a little bit more detail around that. So we needed to make sure that we safeguarded that. Another item that is often a friction when you're looking at data science needs is how do I get it from my prototype, from my research into production? So how can we streamline that process? And that required a great deal of automation along the way to be able to accomplish that. So as we got started looking at our analytic needs, one of the first things that we set apart was we need to separate infrastructure, so infrastructure services. And so by that, we were looking at how do we normalize the data? What is all of our data intake? What is our cataloging of the data? What is the provisioning of the data, provisioning of clusters and the like? How can we create a layer of services around this that can help us in any of our analytic or any of our applications that we needed to be able to build? By structuring sort of the way that we manage the data around that allowed us to, for the people who were focused on building analytic applications or data science platforms and applications, to focus on their value add, which is what are the right platforms, what are the right tools, what are the right techniques that we need to be employing there, whether that be end users that are trying to do research and discovery in the prototype aspect of this, to being able to do any of our analytic queries. And again, the whole idea around this is the empowerment, both of the users, but also of these application teams developing this. So one of our first real challenges that we had, you saw that on our opening slide, that we deal with sometimes up to 75 billion rows of data a day. So we really needed to deal with the scaling of our data plant. That was our first sort of foundational aspect that we needed to address. How do we get all of the data coalesced together into a data lake? Well, S3 was that, basically utilizing S3 as that data platform and that storage around there gave you our storage capability, and we could break down the various different silos. What we wanted to do is any user of the data was to bring their compute or their query or their services against that, you could provision that back up. So we needed to be able to have that. Another big aspect is using both S3 and then ending up using a lot of EMR as well, is that we needed to be able to deal with the resiliency and the disaster recovery. We're a regulator, we're in a highly regulated industry, and we have a lot of strict requirements in terms of disaster recovery and fault tolerance and capabilities that we need to be able to provide on our systems. And so Amazon, running across a lot of different availability zones and in different regions, provides that to us. We also then needed to how could we make this data flexible and easy to find that? And so one of the things we needed to do is have a catalog service around that. And again, talking about the security, outside of the VPC and the encryption that we use both, transparent server-side encryption and KMS in terms of like key management, but a real aspect of designing in from the ground up of all of the various different security services and the roles and IAM roles that went along with that, and automating the entire DevOps. We spent a lot of time retraining development teams around this in terms of continuous integration, so that everything, you have to treat all of your infrastructure as code. So even when you're going in and spinning up a development environment, scripting that all out so that it's part of your build and part of your deploy, so that you could easily rebuild an entire environment, and you would just build it right beside it and tear down the old one that you didn't need anymore. And so that required a lot of exercise to get to there. So when we're looking at scaling the data plant, again, we are heavy users of EMR. So we use them in everywhere from our data normalization and our ad hoc query clusters. Some of these things are transient. We spin up on any day. We spin up anywhere between 25 to 45,000 nodes of EMR every day to process these volumes, both from the data and ETL and from the batch analytics and different, as well as then our kind of constant clusters, and we size them, we grow them based on demand, based on if we got a lot of users that are hitting the system. Because one of the things that we have within our market is that the volumes are highly volatile. So today we need 10,000 nodes to be able to process it. Tomorrow we need 20,000 nodes. Being up on the cloud allows us that, and having separated the compute and the storage allows us to be able to deal with these swings in the data. The other one, when we're looking at the analysis of the data, is that most of the analysis is over the first 6 months or years worth of data. We have to keep 7 years of this data around and online. We have to keep full fidelity. We can't like roll this off. We have like legal requirements around this. So separating the compute and the storage allows us to archive the stuff off or put it onto the lower tier of the storage, but still have that easy access to it. One of the key aspects of what we needed to be able to do as a foundational aspect for any of the analytics is having a really good centralized data management. So again, we used S3 around this, but what are all the services that we built around this? We actually developed this in-house. We open sourced the project. It's called Herd. It's out on JIT that you can go out there and be able to download. What we have is a universal catalog. So you identify every publisher and every consumer goes in. We have a set of RESTful APIs that allows them to register new schemas, new versions of it. We get corrections. We treat all data as immutable. We're over on S3, and so if we get a whole new set of exchange order data from NASDAQ, we'll go and we'll completely replace the existing version. And if you always want to see the latest you have, if you needed to go back and see what did you have as of a certain date, you can do that. We deal with all the storage policies of what we keep in S3 and in various different S3 buckets. It allows us to easily manage this. So again, these higher level functions allow then analytics and applications to actually take advantage of this, and nobody's reinventing the wheel. Another key aspect as we were building this out was having a shared metastore. So when you talk about usage of the data, and we're talking billions of rows, but we're talking hundreds of objects and literally billions of partitions that we have to create across this data. So anytime that you're initializing like an EMR cluster, if you're using like the local metastore around that, it can take up to 7 minutes to load about 1 million partitions. Well, if you're dealing with 1 billion partitions, you're sitting around for hours, maybe days, just to initialize your cluster. So what we wanted to have is the data ubiquity around this. We created a separate Hive metastore over there that could be used by Presto, by Hive, by Spark. And it contained, and we hooked it in with SQS notification. So as you published a new version or a new data set into the data catalog, it published out an SQS notification. Our metastore service picks that up, registers that new table or the partition. So now you can, when you spin up a query cluster to be able to hook into it, you just point it at that EMR, at that metastore, And you can spin up within, literally within minutes to have that query cluster. And it allows us to separate our concerns, and you're not having people step on, if you're sitting in a shared environment, if you got somebody running a really big or data-intensive set of queries, it allows you to separate those concerns. So the net effect of when we're looking at the cloud got us pretty far in terms of having all of our data in one place, giving the ubiquity of the data and the ease of compute. We could spin up clusters, as I was saying, within minutes, and to be able to deal with that capacity and that data constraint. That solved a lot of our analytic needs in terms of within the infrastructure, but there still were problems, or I'll say items that we needed to address in terms of on the data science platform. And for that, I'm going to turn it over to Vincent, and he's going to walk you through more of that portion of the story.
Thank you, Scott. All on? All right. So as Scott said, we moved all of our data into the cloud. We had the analytical capability. We had the ability to query everything. But as far as from a data scientist perspective, we still had some pain points that were left over out of this migration. We had this great ability to call down the data and query the data. But our data scientists hadn't improved their lot yet. They were still using their local machines for what they were doing their work on. They were still had no standard setup. The data scientist was still administering their own machine. That machine was administered differently than their neighbor. It was administered differently than the data scientist in another part of the firm. As we had all this great data out there in the cloud, they wanted to bring more and more of it down. We had more analysts coming in and doing advanced analytics. We had them, calling for bigger machines now also. They had all this data. They wanted to use this data. That laptop, that 16 gig machine they had locally wasn't enough. People started asking for these super workstations, a quarter terabyte of memory. And one of the things we hadn't addressed yet either, which we tend to forget about a data scientist, is they're still developing code. They're still writing code. So the standards of just doing this analysis and collaborating with each other still wasn't being addressed yet with all this. So we had this big gaping need for what we wanted to do from a data scientist perspective. And to give you an idea of what this looked like from a data scientist perspective when we went to the cloud, we had our stuff out there, all our data is sitting on S3. We're using Amazon Redshift, Presto, and Hive SQL to get at our data to do that data processing and pull it across. But what was sitting still on-prem, still left behind for us, was that data scientists still had their one singular machine. They were accessing our on-prem databases. They were accessing their on-prem files, whether they're getting them through email, they're getting them uploaded. So they're still having to manage a lot of work here. It didn't really, their database seemed to get bigger, but from every other thing, they were still doing the same work. So what we decided to design here was what we call the Universal Data Science Platform. Its intent here was to give users, instead of asking for that one single big machine, they were now going to be able to get a machine in the cloud. Technologists and how we looked at it, now we can actually standardize the kind of work, the kind of platform that they were using. The opportunity was there now to, instead of being these disparate little collections of using R with this set of packages, Python with that set of packages, compiled this way, having to administer the thing themselves, technology was going to take this stuff over for them instead. We're going to take care of that for you. We're going to pull down the stuff from CRAN and PyPy. We're going to install it onto your machines. You're going to be very, very happy with what we give you in the end. We also added into all this that came along as a result of all this was Spark came along as another data processing engine. We wanted to give them the ability to use that too. And when we created this, I mean, keep in mind, it seemed like there was the perfect thing here. We had the cloud. We're going to give them elastic compute. They're going to be able to self-service and pull the stuff up. We're going to build this whole thing. And we created what we call UDSP version 1. And we did all the things we thought were right. We took away, all this control, all that stuff of you having to deal with your own machine. We took that away from you. We're now going to take care of it for you instead. We're going to give you that scalable compute. We're going to give you a nice web portal that you go to. You just state what machine you want, what software, what size machine you want, what software package you want, launch the thing and get it all done. We were taking care of everything for you. We were curating the whole thing. We were following all the rules for putting this information up into the VPC. And when we released it, at the end of it all, we kind of turned around and we didn't have any users really using it. And this was kind of an embarrassing thing. We spent all this time, we built this portal, we put it up, they used it when they needed to, and this is when you actually had to go back and step back what happened, what were they asking and what did we do? And IT did the right thing. They were asking for these big expensive machines that were going to be sitting underneath their desk. Let's take this we don't want to give you those big expensive machines, just get the stuff in the cloud. We'll administer those machines for you, and we'll set everything up for you. The users were just asking for more compute. They wanted everything else to stay the same. That local control they had, that actually was a key ingredient to how a data scientist works. And we didn't really listen to this particular part of it. When we did the security, we actually made it secure, but I don't know about you, but you get these requirements from your information security people, thou shalt not do this. One of the funny things that we did is, I gotta look at the slide again. We gave them their machines, they were much more flexible, but we also took away their ability to install new software and experiment with things. It was like verboten to go reach out to the internet and CRAN and so forth and pull those new pieces of software down and build it. We don't want you doing that. We don't know what you're going to be pulling down, so we're going to pull it down carefully for you and build it for you. But that experimentation then turned into technology getting in the way, unfortunately. They called us up, said, please install this package on this machine, and we would then dutifully pull it down, build it, and deploy it out for them, and hopefully it worked for them, maybe a day turnaround. Please put in this JIRA ticket, get this thing done, turn around a day. We felt good about it. But they still wanted to experiment on their packages. Another thing from a security perspective is that when we put this thing up into the cloud, we still had on-prem databases. We had a security rule in place that just said, the cloud stuff shouldn't reach back into your on-prem systems. We don't want to allow that. You reach out to the cloud don't reach back. So I said, okay, fine, that's how we're going to put it into. We'll be all secure compliant. They still need to get their job done. They still needed that data. And our users, being industrious, would pull down the data from the databases that they had, make a CSV file, push it up into the cloud, and then do the data analysis they needed to. You can imagine the reason why they weren't really working on our new system that we gave them is unless they really, really, really needed it, they somehow got by with the local machines they were working on. And we got by with this for quite a while. But it wasn't enough, and again, the calls for bigger machines started coming around. The calls saying the platform you gave us isn't usable, isn't stable enough, doesn't do what we need it to do. So we turned around, listened a little bit more, and we released version 2. And the big change that we added to this was the flexibility. We gave them the ability now to download and install. It was something that was always there in the cloud. We had all this stuff there, but technology ran it. We didn't believe data scientists were coders, but they write code. They need to compile code. So why not give them the tools to do this? They do this on their local desktops. They should be able to do this on their same cloud machines. We wanted to make it from a data availability perspective. We had, like I said, cut off those on-prem databases. We talked to our information security folks, and we said, okay, hold on a second. You said thou shalt not do this. Good question I always ask back to these folks is, explain why. What's the risk you're looking to mitigate, and you do it this way by saying you can't connect between the two? The real concern was we want to make sure you're using secure communications. People are logging onto it. It's an encrypted channel. Data's encrypted in motion. Take care of that stuff, then you can connect back in again through proper ports and firewall holes that we understand. So we did that. It took us some work on our part to look at the databases they were talking to, maybe SSL enable them, and allow them to connect back into the on-prem databases. And the other thing we did in this is we actually changed the ownership model of who was driving the change to this. Instead of technology where we're doing it, tell us what you need, we'll come up with requirements, we'll go implement it, we'll come back to you a couple months later, here's the finished product, use it. We already had in place a community inside FINRA that was called the Data Science Forum. We actually started using that as the ownership forum for the platform itself. Our data scientists are spread throughout the firm. They work in 3 main pockets. But they don't talk to each other too well. But they do like to do data science. They're always a communicative bunch. They are very collaborative in what they do. So we actually gave this forum the ownership of the platform. What goes on it? What are the best packages to put onto it? What features we should prioritize to put onto it? And the best thing being a data scientist and looking back at all this is we actually got good metrics on the usage. 20-fold increase, which was a bit surprising after the first month. One colleague here, when he gave to us, said, what the heck happened with it was called ODAP originally. What happened with ODAP? Suddenly got a 20-fold increase in the bill on AWS. You're doing something wrong was the first response. You can't increase it that fast. My response back was, yes, excellent, people are using it. And that was actually the big feedback out of this. Now, not one group was using it, but now all 3 main groups within the firm were using it. It became useful, it became popular. We did all the things they were looking for us to get done for them and take care of for them, and they were still given control of the stuff that they wanted to have control of. We gave them that turnkey platform. We gave them all the tools that they wanted. We gave them the flexibility that they wanted when they needed it. They didn't want to set up a machine every time they wanted to do their work. They wanted a machine that would scale up when they needed it, and they could scale back down to a smaller one when they didn't need it. So the inventory and what we all put together. So this is just some of the stuff that we have in the data science platform. We support both R and Python usage on here, versions that you see there. Our packages are about 300 is what we have on the platform. The tools we have, everything you need to build it. You know, if you haven't seen Fortran in a while, believe it or not, data science packages, a lot of them still rely on Fortran mathematics. They still need a Fortran compiler to build in the R space especially. RStudio and Jupyter are the two main IDEs that they're using. RStudio Server works exactly the same, whether it's on your desktop or if it's on your Mac, if it's on your PC, or if it's on a Windows, if it's on a Linux server is how we have it here. And that's the other big thing here in what we did, is they're actually accessing these tools through their web browser. So as far as they know, it's still their desktop that they're using it. Jupyter is a notebook that runs inside a web browser. RStudio Server runs within the web browser. Nothing very different from how they interact and how they were interacting on their desktops. One thing we added in the last month is we started using, with the GPU instances in Amazon Web that AWS provides, we actually started allowing people now to experiment with the deep learning libraries. They're still experimenting, so we're building it for them. And this is another example of where technology does what it does well, and we'll let the users do what they need to do. These libraries, Theano, Caffe, and Torch, and the frameworks atop them like TensorFlow are very difficult to compile and get it right. A lot of times people will compile these things, have it on their GPU instance, and they wonder why it's not running any slower, and that's because they forgot some switch someplace. They forgot to point to the right library location where they had the things installed. We take this away from them. They don't have to worry about it. If they're writing in these libraries, they can run it on an instance that's not GPU enabled. The code runs, maybe a little slowly. If they want to have it faster, they can spin up the other instance. They have source control between both versions. They can commit their code into Git on one side, spin up a box with a GPU instance, pull down the code, start doing the analysis. And other things, subtle things we did here, because we made it now easy to move amongst these instances, the other cool thing is now we started, when people were complaining that, wait a minute, I have all this data on my local EC2 instance, how do I get it over to my new EC2 instance? And the response was, have you heard of S3? And we gave them the instructions on how to save their files back down to S3 so everybody on the team can share it. Instead of dictating, we were more or less looking, when they came with a problem, we had the answer pretty much right there ready for them and guided them to a better way to do it. It's one thing to tell people this is the way you should do it. It's another thing when they come to you and say, please help me. Oh, you need help with that? This is how you do it. It's a better way to do it. And they're much more thankful for it. And it's a much more engaging conversation. So the main thing also I want to keep in mind here is this thing is a self-service platform. Technologists are not involved when we're bringing on new members of it, when people need to spin up these instances and spin them down. We completely made this so essentially there's a version of UDSP, it's a software bundle as we look at it, and they say what machine instance they want, what they want on these machines. It's self-service in that they actually they go to a website portal, they say what they want, spin it up, and they're done. We enable people to control that instance that they created. They can start them, they can stop them, they can terminate them. The difference between stopping and terminating, like is marked here, is delete. Sometimes they just don't want to have that extra machine hanging around for too long. But in a lot of cases, they're now incentivized to actually stop the instances if they're not using it. If you go home for the weekend, turn off the machine, turn it back on when you come in on Monday morning. Storage is very cheap compared to all the data that we're storing, so keeping a machine image around for a little while doesn't cost us all that much in the greater scheme of things. And we give them full visibility into all this information. So it's not that we tell them they should be doing this, it's going to cost you a lot, and we don't talk to them for a month or a quarter when they get the AWS bill. We're constantly tracking and we're constantly exposing what their current burn rate is on their instances that they're running. And this actually has a nice, it's a nice feedback loop that results. They're seeing how much they're spending on these machines. They wonder if they really do need that 200 gig machine, maybe a 32 gig machine will do for the kind of work that they're doing. So they'll turn one off, they'll spin another one up, and they'll do the coding on that smaller machine until they run out of space, and then they'll ask for a bigger one. All within their control, all they can do it. And one of the funny things that happened in our experience of going to AWS is there were a lot of times that people would spin up boxes or spin up clusters was actually the bigger cost thing. You know, I heard stories when I joined FINRA back in the summer about people leaving 100 node clusters running over a weekend and nobody doing anything on it. So one of the things we made sure that we added into this is the manager's ability to kill instances that were left running overnight, or if somebody went on vacation, they can now at least shut down that instance so people don't do anything. And that's the extent of how we control this stuff. It's really very simple user control, just what works and enough and not any more than what they're asking for. I prefer to design this stuff from a perspective of if they ask for it, we'll build it, but we'll also have a conversation whether it's a necessary feature or something else might help in the meantime. And to give you an idea of what these screens look like, this is the interface. It's a very simple interface. They go to what we call the Cloud Machine Manager. They ask for the instance. They ask for what software image they want, what machine type they want. This is also bound to the group that they belong to. So maybe some groups don't want their people doing GPU instances. Some groups want them to. No group has yet asked to say, there's certain people on my team I want to have permission to use big machines, other people no. They tend to be collaborative. They tend to all want to use the same stuff. So therefore, it's down to the team, and that's about it. We don't have to do it down to an individual. Then once they start it up, they can also monitor what people are using. And this actually gets you to that web portal instance of what your machine image is. But here you're just getting a viewpoint of just who on my team is running what's my hourly burn rate on my machine. And you can step into each one of those instances and actually look at the details behind it. If you're enabled to, and as an admin, you can actually go and terminate those instances also. So easily to browse amongst all your instances, it gets the information that you need. And finally, once you go from there, you just go to the one little hop-off page. That main portal page brings you to a very simple web page. Somebody must have liked Google at the time they looked at this and just wanted simplicity. Get you to the two IDEs that we have on the server and gives you some reference points, and that's it. And as you can see with the RStudio server instance that we have there, I wasn't lying. We actually, if you can see a scroll bar, there's a lot of packages that are there already installed and ready to go for them. It's all just right there. But we wouldn't be done with a data platform like this if we didn't think about what it takes for maintaining this going forward. We did all this work to get it up and get it running and have it, but how are we going to control who wants what libraries, how this is all going to come together? So what we did is, again, it's a community-driven experimentation viewpoint on all this. We made it enabled so that people can install whatever they want to onto those machines if what is available on UDSP is not there. They are incentivized to make it part of the standard platform because they want to be able to hop amongst these machine instances as much as they can. We made it easy for them to do that. They actually would prefer to do that rather than maintaining one machine themselves all the time. Once you take maintenance out of a user's hands, a data scientist's hands, and technology is doing it for them, they don't want that experience anymore. They'd rather us take care of it, but they want to experiment. And our philosophy on this is the approach that we take on this is we vet the libraries through the data science forum, and then we propose it to the forum. We essentially vote on it. It's either, yes, we like it, no, we don't, and it's proposed and then installed in the next version of the data science platform. And our releases are right now running at about a monthly rate. We're still adding features onto the platform as we're going. I suspect into next year, we're probably going to cut this down to about a quarterly rate. And from a production movement, this is the main platform. This is the foundation, the bedrock that you start all your work on top of. If you want to write an automated job atop this, I need this instance up and running. I'm going to automate jobs to it. This is the bedrock platform version I'm running on. And here's my code that's running atop that from a scheduled job perspective. So they always still have the freedom to override what's in the underlying platform. And that's what R and Python both give, because you can give multiple locations for where your libraries exist. We just give them less of a reason to have all these libraries in their own application store. And our philosophy from a releases perspective, and this is something I took from my previous firm, is the experience is that the .0, .1, .2 versions, especially things like R that runs on a yearly cadence, have some new features, but the libraries are kind of lagging in what it can do. It's not as stable yet until it gets to the later patches. So the philosophy here is we're just taking the last patch version of the last release. So in the case of right now, when we put the slide together, 3.3.2 just got released a couple weeks ago, but 3.3.2 is now the current R version that's out there. That's the bleeding edge, but we're actually running 3.2.5 out there. And we just found that that's the better. we kind of increase our odds to have stable libraries and a stable R platform by doing it that way. And these folks nobody's been chomping at the bit to get a 3.3 running in their platform. And the same approach from a Python perspective too. So, what's next? The data science platform isn't complete yet. The one thing we've done, we've taken this journey from having our data on these servers and pushing that up into the cloud to having these boxes under our desk that weren't enough to now using the cloud to lever this compute. But the one thing we're still missing is essentially where we're going with our advanced analytics platform. And that, instead of going from a single machine, no matter how big of a machine Amazon can give me, it's not going to be enough for the data processing we need to do. So clusters for our analytics is going to be the next thing. And the driving force behind that is going to be the surveillance platform that we're building out. I work in market reg, and the job here is to use machine learning to catch the bad actors in the markets that we're collecting all this data for. So we want to build these surveillance patterns based on machine learning. So as part of this platform, it's going to have two main components, a data framework and a machine learning framework. The purposes here is essentially push reusable, shareable code into these frameworks. This sounds pretty simple from a computer scientist perspective, but from a data scientist perspective, they generally just copy code. And reusability is an example code to copy. We're going to be putting it into these frameworks, and people are going to be using it this way instead. And the full stack actually looks like this is what is going to be our vision for next year to be building out. Spark is that underlying platform. Originally, it was an RDBMSs that we had. Then we have Hive, Presto as our SQL engines on, and Redshift, but now it's actually going to be Spark underneath that. With Spark, we now have the ability to not just use SQL that everybody knew very well, but we can now use R and Python that the data scientists already know, and Java and Scala as more of our data engineering languages atop that. The data framework is all those common data manipulations. Scott mentioned we have that data catalog. Herd, or the data manager that we have internally, this was a godsend. When I came in and I heard that we had this, it was like, you actually have registered in one central location where all the data is in market reg. Every S3 file, every schema, every version of every schema of every file data set that we have out there is registered in DM. And you heard Scott mention that it's a REST API. This is one thing where essentially we brought it up this far, but from a data scientist perspective, they didn't really understand REST APIs too well. So we created a data catalog Scala class in between to work with Spark. The purpose of the data catalog is very simply for every object we have registered out there in DM, we can now create a Spark data frame for that on the cluster that we're running on. And now with that, those data manipulations in the data framework work at a data frame level. They're not working at any kind of weird data files or anything else. It's a tabular level type work. You can do the map reduce work, or you can do joins and sequels and window functions and everything else. Everything that Spark is giving you, we can now take advantage of. Then once we have our data shaped, that's where the ML framework comes into play. This is where we're going to be doing our work to have best practices on these libraries on top of it all. Utilizing cluster-based machine learning algorithms coming from H2O or MLlib, we're going to have all the best practices of how you actually properly partition the data that you're working with, to train the models, to compare the performance metrics on them, to document essentially why this is the best model we have for the data that we're looking at, and then deploying that model on this framework into our production. And the patterns themselves will be built atop all of this when we push it all out. So to recap and where we've been with all this. One of the things I found interesting when Scott and I were going through this deck and what we're going to be talking about is how every time we did one thing, made one thing easier, suddenly exacerbated a problem in another area. It was a funny thing of essentially, okay, we're choked on the database, we choked on the data that we have on the system. How do we get this data now, make it easier to have more data, all 7 years of high fidelity data available to them? We're going to go to the cloud, we're going to have the elastic compute, elastic storage. Then the next thing that happened is people want to actually now use that data. Using that data meant they had to pull it onto a machine that was capable of analyzing that kind of a large data set. Well, the things they had under the desk weren't enough to do that, so we had to go to the cloud and move that up there. And the next thing we're envisioning when we're doing that is that same breaking point is going to occur on those single machine instances. You're either not going to pull out of that data down to one machine, or you're not going to be able to analyze it in a timely fashion on the one machine. You want to scale out now to clusters on top of it for the analytics side of things. Flexibility, that was like one of the most surprising things that we learned as we were going through this, that flexibility for the data scientists to still experiment, to still try things, to not make it such a walled garden that we didn't allow them to download software, try it out, see if it was worth using, and they're proposing it back into the standards. We kind of looked at this platform in the version 1 as this sealed box that we're going to put it all together and they're never going to ask for any changes, or else it's going to be another version that'll take 3 months for us to push out or something. We looked at it as much more of a software product rather than a flexible platform that allow some experimentation, some standardization, and we did a push and pull between those two. And as a result of it, we actually separated the groups, and we each do what we're best at. Data scientists can do the analytics. The technologists are actually the ones administering the infrastructure, the software packages, and everything else underneath. And that's probably the biggest thing here on the framing of things is technology get out of the way. We just got in our own way of getting a proper solution out to our end users. Listening to InfoSec rules, but not asking back why you needed that rule, what was the reason behind that rule, and putting it out there and coming up with an alternative that still met the same standards that they had, but we were able to put the stuff out. And as we're into our budget season, where we're doing things now, the funny thing is now we're reintroducing back to our users again this whole concept of compute is now a cost they have to manage. They never had to look at this before. We're telling them how much they're running their software is costing, running their analyses are costing. But we're actually allowing them to do the cost-benefit analysis. Is it worth me asking for this bigger machine to do this thing in half the time, or can I wait for it to happen on a smaller, cheaper instance of a machine? Technology is not in the way of these decisions. We give them all the power to monitor their costs, all the power to ask for the types of machines they needed. They can actually make those decisions better than us playing traffic cop, and where we only know half the story anyhow, which is generally do it as cheap as you possibly can. And that's it. We're going to be opening us up for questions in a moment. Just wanted to put out this little thing here that FINRA, we just completed a big move of putting all that data that we talked about into the cloud. And we have a couple of other sessions going on here that we're sharing our experiences with getting this done. As you can see up here, these mostly are occurring, I believe, Thursday and Friday this week. So if you're interested in this talk and want to learn more, go to these sessions. And I'll give you one more slide to take a picture of if you want to come back and ask Scott or I any questions. Those are our LinkedIn profiles and our email addresses and welcome questions. I'd like to hear what your story is and how you're getting through all this. And now our little thing we're going to open up for questions. If you're curious about technology at FINRA, these are the web links. I think like everybody else around here is giving a talk, we're hiring. So if you want to work on the East Coast in the Rockville, New York area, you can take a look at the careers we have there. You can ask Scott or I what it's like working here. And lastly, thank you. So with that, we've got 2 mics here on either side. Welcome any questions.